This is the chapter 22 homework, and oh, I guess I forgot to do the first problem. Okay. So if you earn 1 point on your final exam, does that mean you're ranked number 1? No. So I would say that that's not a rank. Okay. A rank is when you're comparing a certain group of things to each other. So then whatever's the highest is ranked number 1, or whatever the best is ranked number 1, and so forth. Okay, then so let's see if these are which of these involves 2 independent groups. Pretend like you can't see the answer. Homes and their age. Well, homes and ages both have quantitative values, so I would not pick that one. So this part B has 4 different groups, and you should only have 2. You should be comparing 2 groups. Part C, height of water is a very quantitative type of measurement, so you should probably use something else to do that with. Part D, this is a qualitative measurement. You just rate the sweetness of a drink from 1 through 10. And you have 2 independent groups, teenage testers and adult testers. So this seems perfect for a Wilcoxon-Rank-Sum or Mann-Whitney test. This chapter is about non-parametric tests, by the way, which are called distribution-free statistics. A lot of them are based on ranks rather than actual numbers. So, like rating something from 1 through 10, instead of measuring how many inches something is. Okay. So this would be a panel of consumers, so it'd be one group, so it wouldn't be independent. They'd be comparing things, but it would not be an independent comparison, because it's the same panel. Okay, so that's why I picked D. So the earthquakes in the Pacific and the earthquakes in the Atlantic are pretty far away, so you could just assume that they're independent of each other. In other words, if an earthquake happens over in the Atlantic Ocean, it's not necessarily going to cause the one to happen in the Pacific Ocean, and vice versa. So since it's a comparison of 2 independent groups, it would be good to do that test. Wait. Okay. Now, Spearman's rho. So Spearman's rho is exactly like the normal correlation coefficient R, except you replace the numerical values of each variable with their rank, and then you do the same exact calculations. And what you come up with then is called Spearman's rho instead of Pearson's correlation coefficient. So downloads of a new smartphone game might go very extremely high or extremely low, So it could fluctuate wildly. So if you just ranked them and said like the highest amount of downloads, the second highest amount of downloads, etc., then the number of hours since it has been released, it would be appropriate to do Spearman's Row on that. So, especially when there are outliers, and there could be outliers with the new smartphone game. It might have a really high amount of downloads during 1 or 2 hours and then go down a lot more during the rest of the hours. Okay, so this one is called the Quaskell-Wallace test, trying to see if two or more, well, if multiple different populations have the same probability distribution. So the hypothesis is that all the populations have the same distribution. The alternative is that the populations do not all have the same distribution. So it could be 2 of them do, but 1 of them doesn't, or it could be all of them that don't, etc. So answer number D is wrong because it says the populations all have different distributions. They don't necessarily all have to have different distributions. It could be that some of them do and some of them don't. So the null is that all of them have the same, so every single one of the populations has the same distribution. The alternative is that they don't all have the same distribution. Some of them might have the same, some of them might not have the same, but they don't all have the same. So part C is the right answer. Then the way to do it is you click on the data table, click on this icon, click on Open in StatCrunch, and then I'll show you the options. Compare all the columns and then just click Compute. And you can leave everything else the same as it is. And then the statistic is a chi-square statistic. One of the reasons why it's such an awesome statistic. And then you get 2.36. I rounded that off. P-value of 0.308, which is fairly large. So it's larger than alpha, so you'll fail to reject the null hypothesis. So that means that the cuckoo eggs couldn't have the same distribution as the other birds. So, what does this mean? This means that it's not necessarily true. There's no strong evidence proving that cuckoos change the size of their eggs when they lay them in different birds' nest. So cuckoos are really bad birds. They destroy the eggs of the parent birds, and then they lay their own eggs inside of the nests, and then the parents raise the cuckoo birds. Sounds like a lot of lazy people in the world. Alright, well that's that. Then, so see this data kind of curve, these data kind of curve, sort of like it's bending, and like instead of going straight from here to here, it curves around and then bends sideways at the bottom. So when it's close to -1 or +1, it's fairly strong. If it's negative, then it would be a negative. So strong negative, Spearman's Row as well. What would make these data the appropriate choice? Because of the nonlinear relationship. So there's nothing to show us that it's skewed or has large outliers, but it's definitely a nonlinear relationship. Alright, that's it for chapter 22.